Alright, this is lesson 57 for Algebra 1. We're continuing on a statistics section, and we're talking about scatter plots. And scatter plots are when we want to compare two things together to see if they're related. And we try to do that all the time. Medical field does it a lot. We relate things together to see if there's, a correlationship, okay? And sometimes we could fit a line. We looked at fitting different sorts of functions yesterday, linear, quadratic, and exponential. And we do that so that we could predict what could happen, because if we know where the line is going, we could easily see, we could predict what would happen in a certain case or scenario. So the purpose of this, the concept here is we're finding the line so we can predict what's going to happen, okay? Does that make sense? For example, let me give you an example. Let's say today it's going to be 70 degrees. Tomorrow it's going to be 75. Thursday's going to be 80. Friday's going to be 85. What do you think Saturday is going to be? 90. Why did you say that? It's going up by 5s, and it's actually going up in a straight line by 5s. The slope would be 5 over 1, right? Does that make sense? So Sunday it's going to be 95. That's what we predict. Does that make sense? Okay, we predicted that with a line. All right, continuing here. These are the steps for today. If you're on the video, please pause it. There we go. So let's say these were scatter plots, okay? Usually they don't come with a line, but today I'm putting the line there kind of like training wheels so we can see what happens, okay? But tomorrow we're going to have to figure out what the line is and do it ourselves. So most of our points on this scatter plot, let's say we're comparing two things. Most of our points are right here, okay? And so we're noticing they kind of go up in this direction. So you would draw a line that's already here, okay? And so that's called the line of best fit. It means that if I were to put a line and all the points would be equally far away from the line, okay? If we were to add them all up and subtract them, they would have the same average distance away from this line. This is called the line of best fit, okay? Okay, it's called the line of best fit. So, the goal today is, tell me what the function is of the line of best fit. So I'm noticing here, if I look closely here on the screen, I'll actually turn off the light so you can see it better. But on your homework, you'll see it really well. I'm noticing that there's a grid here, so I need to find what the y-intercept is, because I need to find an equational line that follows y is equal to mx plus b. So our y-intercept here, or our b, is equal to 1. And we're trying to find a slope, so I'm going to pick this point, and I'm going to pick one more point and try to find the slope. Let's say I wanted to pick this point here. It could be any point, 2 points on the graph. I want to see what's the rise of a run. Well, the rise is 2, so our m is going to be rising 2 and running 1, 2, 3, 4. So if I were to simplify this, our m is really 1/2. So if I were to write this into our equation, y is equal to 1/2 x plus 1. Okay, that's the slope of this line. And what is this telling me? Okay, it's telling me that this data is increasing at a rate of 1/2. So if I were to look at something like, let's say I were to predict something that's way out in the on the x-axis, way out here, I know it's going to be half as high as it is far to the right. Okay, so it gives me a bit of a prediction. Does that make sense? Just like I talked about earlier, for every day we move forward, we're going to increase the temperature by 5 degrees. Okay? So that's how you do number 1. Watch me do number 2. Again, the lines won't be here tomorrow, but today they are because it's kind of like training wheels, okay? So all of these there's a bunch of points here. This is our scatter plot. Let's say we're comparing two things. Let's say it was engine size compared to, let's just pretend to gas mileage, okay, or miles per gallon. We've done this one before. So as the engine size gets bigger, gas mileage gets lower, right? Y'all see that? So if I were to draw a line to connect all the points in a line of best fit, it would look like this. So the first thing I want to do is I need to make an equation. It looks like y is equal to mx plus b. First thing I want to do is find the b, okay, or our y-intercept. So this one's pretty high up there, so I'm going to have to count it out. count up here. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so this one goes up 15, so our b is equal to 15. Okay, next I'm going to figure out what my slope is. I'm going to pick 2 points. I'm going to pick them pretty close as soon as I find them crossing the lattice points. There's one right here specifically, so I know that it's rising -2. So our m is going to be -2, and it's running +1, 2. So if I were to simplify this, our slope is really like saying -1 over 1, or just -1, okay? So we just write these in, substitute these values. So y is equal to -1x plus 15, or it's really like saying y is equal to -x plus 15. Okay, and that's all we're doing today, okay? And what is this telling us? It's predicting that as the line gets bigger, or as our x's get bigger, your slope is getting smaller. Does that make sense? And the highest miles per gallon is 15. You see that? So it's giving us a point of prediction, okay? Any questions on this? Feel pretty good? Give me a thumbs up if you got what I just said. Pretty good? Okay, cool. So let's have the, today's Tuesday, let's have 2's tell the 1's about number 1. Let's have 2 start, and then 1's tell 2's about number 2. Ready, set. Okay, number 3, okay? Nah, just on your papers. Okay, so number 3, we're noticing that there's a bunch of points and the line is there. Again, tomorrow will you have the line drawn in there for you? No. Today we're just figuring out what the equational line is. Okay, good. Wow, that was very in unison. Okay, it's unusual. All right. Okay, so right here I want to, this is a point right here, so, and I'm going to tell you this is 1, 2, 3, 4, 5, 6, 7. So our b is going to be 7. Slope, I'm going to pick another point for you. Let's see, I'll pick this one right here. It goes down 1 and over 1, 2, 3, 4. So our slope is -1/4, okay? Can you write me the equation of the line for me, please, for this particular scatter plot? Is equal to what? X. Good, there you go. That's it. Number 4. Okay, what's our y-intercept on number 4? It's kind of hard to see, right? Okay, I'll help you out. It's hard to see from there. So this is actually 1, and then this point here is, this is a 1, and then there's 3 more. Okay, is that helpful? Okay, so use that as your guide. That's enough information. Y is equal to what? What is it? 4. 4x what? Plus what? 11. Plus 1, right? There you go. That's your answer. Okay, this is like drawing a line, right? Do y'all see that? Want to do a couple more? Yeah. Here we go. Number 5. What do you notice about number 5?
Straight line.
Is there a slope?
No.
No. Okay, so I'm going to put the dashes in for you so you can see from afar. On the video, you can see fine. Okay. That's enough information to do this problem. Go. Okay, so in this example, we counted our y-intercept 2, 3, 4, 5, 6, 7, 8, 9. So b is equal to 9. And is there any slope on this line? No. It's not rising at all. If I pick 2 points like this point here and this point here, it's not rising but running 2. So if our m is going to be rise over run, it's rising 0 over 2. 0 divided by 2 is still 0. Okay, so if you're plugging this in, it would be y is equal to 0, x plus 9. 0 times x is 0, so y is equal to 0 plus 9, which is just y is equal to 9. That's your answer, right? What does this tell me about the information here? No matter how big this one gets, this one stays the same, right? Does that make sense? Y'all following me? Or this could be an example of the x could be grade and time at school. Okay, when you're at, believe it or not, you're all at school, I think, from kindergarten up to high school. It's pretty much the same. So, your time at school is always the same, no matter how old you're getting, until you're graduate, of course. Okay, last one, number 6. Is there a line on number 6? No. Would I be able to draw a line that connects all my points nicely? No, you can't. There's no real perfect way. They're not bunching together. You notice how, like, on number 5, they're all bunching together right here? And there's a line there. Are they bunching together anywhere here? They're just pretty random, which means there is no correlation. You can't really, like, draw a line. You could draw infinite amount of lines, so we don't know what the line is. There isn't a perfect line that goes through all of these. So when we say that we'd say there's no correlation. Okay? Okay, so that's just the example. I want you to see that. And that's it. That concludes this lesson. So turn to your neighbor and talk to them about these things.